Hello, this is Mr. Collier, and today we're going to be graphing quadratics in standard form. Okay, first we have this starter, which actually has nothing to do with standard form, but let's do this. If you want to skip straight to standard form, you can move ahead in the video. Okay, so firstly, the equation of the line in standard form between these two points. First thing we need to do is find the slope. Okay. So we always need to find the slope when we're finding the equation of a line. So remember, the slope is y2 minus y1 over x2 minus x1. Okay, so that equals, in this case, 8 minus 4 over 6 minus negative 2, which equals 4 over 8, which equals half. So we have the slope equals half. And we have 2 points in the line, so actually we can start with point slope form. Recall point slope form is y minus y1 equals m times x minus x1. Okay, where x1 and y1 are any point on the line and m is the slope. So I can just use one of these points. I'll use 6, 8 because they're both negative. So y minus 8 equals the slope times x minus 6. Okay, so that's the equation of point slope form. We want this form, standard form. Notice that we got everything on one side and 0 on the other side. We have to have integers, so I'm going to actually multiply everything by 2. Okay, we'll multiply both sides of the equation by 2. And then we get 2y minus 8y equals, well, the 2.5 cancels, so we have x minus 8. Okay, next we will get 0 on one side. I have a mistake over here actually first. 2 times 8 is actually 16, so let's get 0 on one side. We'll subtract x from both sides, and then we'll get negative x plus 2y. And we'll add 6 to both sides, and we'll get minus 10 equals 0. And often, they don't ask you in this case, but often we want the value in front of x to be positive. So let's multiply everything by negative 1, and we get this is our final answer in standard form. Okay, so that's the standard form of a line. Later, we're going to be doing standard form of a quadratic. Okay, next we're going to look at the distance between point A and B. So recall the distance formula is kind of like Pythagorean theorem. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, where x1 and y1 is a point and x2, y2 is another point on the line. So we have these 2 points. Let's plug in the values of x. So we have 6 minus negative 2 squared plus 8 minus 4 squared, and we get square root of 8 squared, which is 64, plus 4 squared, which is 16, so we have root 80, which if you like, you can simplify to root 16 times root 5, which is 4 root 5. Okay, next we'll find the midpoint of line segment AB. And recall the midpoint is just going to be the average of the x values, and the y value of the midpoint is going to be the average of the y values. Okay, so we just find that average by adding them together, divide by 2, and we have 4 over 2 and 12 over 2. So we have 2, 6 is the midpoint. Okay, next we'll be graphing a quadratic here. Actually, first let's look at this information, some pointers on how to graph a parabola when it's in standard form. Let's look at number 2 first, actually. This is always the case. You can get the y-intercept by plugging in x equals 0. But if you plug in x equals 0 to a quadratic in standard form, then you just get c. So c is always the y-intercept. C is always going to be the y-intercept. Now, so that's pretty easy to get in standard form. Which way is the curve? Well, if a is positive, if a is greater than 0, then it's pointing up. If a is less than 0, then the parabola will be pointing down. Okay, and where's the axis of symmetry? Well, you can get the x value of the axis of symmetry using the very important little formula, negative b over 2a. That gives you just the x value of the vertex. And then to get the y value, you can plug in x to get the y value. What are the x-intercepts? Well, you have to sub in y equals 0 and solve for x. Sometimes that's easy. Sometimes you have to use quadratic formula. Sometimes there's no x-intercepts. For example, this parabola has no x-intercepts, so you'll get no answers using the quadratic formula. Okay, so let's actually look at an example. We're going to graph this one here. I can see right away that the y-intercept is going to be 8. So y-intercept is 0, 8, so I can plot that. Okay, so let's graph that y-intercept of 0, 8. Here it is. And next, we can get the axis of symmetry. So x equals negative b over 2a, which equals, in this case, negative 6 over 2 times 1, which equals 6 over 2, which equals 3. Now that's just the x value of the vertex, and it's also the axis of symmetry. So I could start drawing the axis of symmetry here, and I'll label it x equals 3. So the y value at the axis of symmetry, we can substitute in 3 into the equation. We get 3 squared minus 6 times 3 plus 8, which equals 9 minus 18 plus 8, which equals 9 minus 10, which equals negative 1. So 3, negative 1 is our vertex. Let me redo that. Okay, so we have the vertex. We know what faces up because the a value is 1. So actually we can, there's no vertical stretch, so we can actually plot some more points now. We can go over 1 from the vertex and up 1. And then we can go over from the vertex 2 and then up 4. And then because it's symmetric, we have the same points on the other side. Okay, we can get one more. I can go over, actually no, the y-intercept already is 8, so that means there's another y value of 8 over here because it's symmetric. And then I can draw the parabola as so. Okay, let's look at another example. So let's get all of these things here. The y-intercept is the easy one. It's 0, negative 3. You can get that directly from the equation. Direction of the opening is up because a is greater than 0. Axis of symmetry is x equals negative b over 2a. That's negative 2 over 2 times 5, which equals 2/10, which is 1/5. Okay, so it's going to be a vertical stretch by a factor of 1/5, so it's going to be a bit of a fat parabola. I can start putting in some of this information. The y-intercept is 0, negative 3. Oops, let me get that right there. Okay, 0, negative 3. Axis of symmetry is 1/5, so that's very close to the y-axis. Okay, I didn't do such a great job here, but that's x equals 1/5. Should be very close to the y-axis. Now, because there you get the vertex, or the y-intercept's at 0, negative 3, then because of the symmetry, you're going to have another point over here. And let's get the roots. The roots, you set 0 equal to y, and we'll solve. And does this factorize? Yeah, I think it does factorize. We need two numbers that multiply to give you negative 15, 5 times negative 3, and to give you negative 2. Those numbers are negative 5 and 3, so this factorizes. We have 5x squared minus 5x plus 3x minus 3, so 5x minus 1 plus 3x minus 1. So that should be 5x, sorry. So 5x plus 3 and x minus 1. So the x-intercepts are x equals 1 and x equals negative 3 over 5. Okay, so that's our two, that should be 5 right there. Negative 3 over 5. Alright, so negative 1 is over here. And negative 3 over 5 is over here. Sorry, positive 1 I need, which is over here. Alright, so I think we have almost enough information. We don't have the vertex yet. We have the x value of the vertex is 1/5. So to get the y value of the vertex, we do y equals 5 times 1/5 squared minus 2 times 1/5 minus 3. That is 1/5 minus 2/5 minus 15/5, which is negative 16/5. So the vertex is 1/5 negative 16/5. Okay, negative 16/5 is a little bit more than negative 5, or a little bit less than negative 5. Okay, so we're at 1/5 down. That kind of makes, that's negative 3, sorry, a little bit less than negative 3. That kind of makes sense in our graph here. So I'm going to try to plot that. So our parabola looks like this. Okay, I did not do a good job because it's hard with this drawing tool, but it should go through right there. Actually, that's a pretty horrible job. Let me try that again. Okay, there we go. It's not too bad. Okay, next we're going to look at just using the discriminant to figure out how many roots there are, or how many zeros there are, or x-intercepts, 3 words that mean the same thing. So recall, you could have no x-intercepts, you could have 1 if it touches at 1 point, or you could have 2 x-intercepts if it touches at 2 points. So there's 3 possibilities, right? And you can determine that with just a discriminant. Okay, if the discriminant is bigger than 0, we have two roots, or 2 x-intercepts. So let's calculate the discriminant. It's b squared minus 4ac. In this case, it's negative 6 squared minus 4ac is 36 minus 32. That is positive. It's greater than 0. Therefore, we have 2 roots, right? So we're not actually calculating the roots. We're just saying that there are 2 roots. Okay, the next one we have the discriminant equals positive 2 squared minus 4ac. So that's 4 minus 4 equals 0. When it equals 0, there is only 1 root, because you only get 1 answer here. You get positive negative root 0. So there's only 1 answer. And over here, let's do the discriminant. We have negative 2 squared minus 4ac equals 4 minus 60. So that is definitely negative. That means there are no roots, or 0 roots. Let's say no roots.